So today we are going to be talking about Newton's laws. Newton's laws are important because they allow us to show the relationship between forces that are acting on an object. They can be used in order to describe both contact forces, such as something being pushed along a surface or something being thrown in the air, and non-contact forces, which would be something such as magnetism or buoyancy or lift or thrust or something like that. So, as you probably know, there are three of Newton's laws describing motion, and they are all extremely important in order to understand the relationship between forces. So, let's get started. Newton's first law of motion is often called the law of inertia. It states that an object at rest tends to stay at rest unless acted on by an outside force. Similarly, an object in motion tends to stay in motion unless acted on by an outside force. Now, in general, Newton's laws can be a little bit confusing because, after all, we know that this isn't actually how things tend to work in reality. For instance, if I were to push a book along a desk, when I let go, it will keep traveling for a little bit, but then it will slow down and stop pretty quickly. And the reason for that, obviously, is the friction between the book and the table. However, if you were to imagine a world where this friction didn't exist, this law would start to make a lot more sense. After all, if I take a hockey puck and place it on a ice rink, if I were to hit that puck with a hockey stick, it would go on for a very long time before stopping. In fact, normally it would hit a wall or something else first. In this way, because the friction is lower, you can see more clearly how this applies to theoretical situations. And after all, the friction isn't something different. It's a force. It's a force acting opposite to the motion of the hockey puck. In this case, we talk about something called the coefficient of kinetic friction as opposed to the coefficient of static friction because the puck is moving along the surface. Anyways, this law describes how the motion of an object changes in a perfect world scenario where there won't be forces such as friction or air friction. Next, we have Newton's second law of motion, which can quickly be described by the equation F equals ma. The law states the acceleration of an object is directly proportional to the net force acting on an object. This equation is really important for understanding how we solve for one of the variables in this equation. For instance, if we know that if we have an object falling from the sky, we'll know that the gravitational constant on Earth, acceleration, is always going to be, not always, it depends on your position on the Earth, around 9.80 or 9.81 meters per second squared, whereas we'll know that the mass of the object is always, it's whatever the mass of the object is, it's not going to change throughout the fall unless it's evaporating or something, but we won't be dealing with that. So then we're able to solve for force with this relationship. In this way, understanding this equation is really important for me to be able to solve problems in the future in the next video. Finally, Newton's third law of motion states that for every action, there's an equal and opposite reaction. This law is important because it explains why, let's say, when you place a book on a table, it doesn't just fall through the table, it stays there. The reason for this is that although there's obviously the gravitational force pulling down on the book, we call that mg for mass times gravity, coming from force equals ma, it's also something called the normal force, pushing in the opposite direction with the same magnitude, causing the book to stay still. This law also explains forces such as thrust and lift and buoyancy that they're not quite intuitive, yet we can see that they are obviously there because of the mechanics we're able to build. So understanding these three laws is really important in understanding how to draw force diagrams and solving problems in the next video. Thank you.